Hi there, this is a tutorial on how to balance or deduce redox equations using half equations in acidic solutions. This video covers the IB course for chemistry, SL and HL, but it's also relevant if you're doing A-levels or an equivalent course anywhere you are. I'll do the video assuming that you're okay with deducing redox equations using half equations in normal solutions. So I'll run through how to deduce these half equations first of all, and then we'll work on how to actually balance or put the two together into one redox equation. The particular part of the course that it's relevant to is the application skills of 9.1 of the IB chemistry curriculum, which says deduction of redox reactions using half equations in acidic or neutral solutions. And what I'll be focusing on is this acidic bit, because they're quite tricky, and I find that students find this particular part really hard. It only really comes up in very long questions on a paper 2, very rarely on a paper 1, but when they come up on a paper 2, they're juicy questions, and if you can get all those marks for it, you're in a good place. So let's look at half equations in general first of all. Now most half equations are very straightforward. If I look at this one, for example, it's unbalanced. If you get anything like this, the first thing you do is you balance the number of atoms. So I've got Cl- over here and the Cl2 here. I need 2 chlorines on this side in order to make sure I've got the right number of atoms on both sides. But I've also got to balance the charge. So on this side I've got 2 lots of Cl-, which is 2-. Now I need the same on the other side, so I need to add 2E-, and by adding the 2E-, I've added 2 electrons. Now if I look at this example, similar idea. This time I've got copper going to copper 3+. In this case, both atoms are actually balanced. There's 1 on either side. It's just the charges which don't. Now on this side I've got 3+, which introduces 3 positive here. Now in order to counteract that, I need to add electrons. But because this is the highest positive charge, the electrons have to go on this side. You won't add them here because it just takes them further away from the 3+. So I'm going to add 3E-. Now that adds a 3 negative charge. They balance out to form an overall charge of 0, which matches here. So it's good, that works. So you can see most half equations you get are pretty straightforward. In acidic solutions it's a bit different, because what you've now got to deal with is some oxygen that you might need to balance out as well. Now if I just balance the vanadiums and the charges, that's not enough, because I've still got the oxygen to deal with, and that's when we have to have a different technique. Now this is the step-by-step process I recommend for going through this. First off, you want to balance your atoms. So in the case of what we've seen before, you either balance, the vanadiums or the coppers, whatever it is that you have to deal with. Except for the oxygen and hydrogen, that comes later. Your second step is to balance number of oxygen atoms by adding water, and that's usually on the product side. You then have to balance the number of hydrogen atoms by adding H+, and that's usually on the reactant side. You then have to add electrons to balance the charges, and then finally check your answer, which is the more straightforward step. So let's put this in practice. So here I've got VO3- making V2+. Alright, so I'm just going to write out again, just for clarity. So VO3- making V2+. Now the first thing it says is balance the atoms. I've got 1 here, I've got 1 here. It doesn't need any further balancing. We're good. Let's move to a second step. It says balance the number of oxygen atoms by adding H2O. Now I've got oxygen here and I've got 3 of them. So I need to add oxygen on the other side to balance it all out. So I've got plus H2O. Now I've added oxygen, but there are 3 here, and I only have 1 there. So I need to have more in order to balance this side with this side. So I'm going to put a 3 there. So I've now got 3 oxygens here, 3 there, it's balanced. Okay. Next step, we're going to balance the number of hydrogen atoms. Now, because I've added water, I've added hydrogen. I've added 6 in total, and I need to have the same on the other side. So what I'm going to do is I'm going to add 6H+. That's the red. Now the reason why I've added 6 is because I had 6 on this side, and I needed 6 on this side to make the whole thing balance out. So that now works. Final thing is I need to add electrons to balance the charge. Now in order to do this, I need to work out the charges on either side. The 6H+, it's 6 lots of 1+, which means it must be plus 6. I've then got VO3-, which is a -1. So overall that's plus 5. But on this side I've only got one thing that's charged, which is the vanadium, which is plus 2. Now, in order to get them to the same charge, I need to add electrons to one of the sides. It has to be this side because it's the most positive charge. And to get from 5 plus to 2 plus, I need to add a 3 minus. So that's 3 electrons. And then you're done. The only other bit I have to do is I need to check my answer. So let's just double check our balancing. I'll do it detailed for this step, and in later examples probably not so much. I've got 6 hydrogens. I've got 3 lots of 2, just 6 hydrogens. I've got 3 oxygens. And here I've got 3 lots of 1, which is 3 oxygens. In terms of my vanadiums, I've got 1 vanadium, and here 1 vanadium. So they balance. And as you saw from over here, these charges balance. I'll just double check it once more. That's plus 2. Here I've got minus 3, minus 1, plus 6, which equals plus 2. So they balance as well. So we're in a good place. Charges balance, atoms balance, that's my half equation. Let's try another one. Here I've got MnO4 minus, this comes up quite a lot, going into Mn2 plus. Again, we'll go for the same process. I'm going to write it out again. So MnO4 minus, making Mn2 plus. Now, the atoms are already balanced for the manganese, so that first step's already done. So I've got 1 to 1. Next step, I need to balance my oxygens. Here I've got 4. So to make the other side work and balance those oxygens, I also need to add oxygen in the form of H2O. But because I have 4 of them here, I also need 4 there, so that's a 4. Next step is to add hydrogen atoms by adding H+. Because I added the water, I've got 4 lots of 2 hydrogen, which is 8, so I also need 8 over here, so it's 8H+. I'll just tick that off. Finally, I need to add electrons to balance the charge. You really need to work out the charge step first. Don't try and cut corners here. The amount of mistakes you can make by doing that is large. So I've got 8 plus, take away 1, now that gives me plus 7. Over here I've only got plus 2. This has got the most positive charge, so it would make sense to add electrons to this side to bring that down. So to go from plus 7 to plus 2, I need to take away 5. So I need to add 5 electrons here. Okay. And then really quickly check our answer. We'll do that now, real quick. Manganese to manganese. I can see 1 over here and 1 over here, so they're good. Hydrogen, I've got 8. And this side, 4 lots of 2, also 8. That's good. Oxygen, I've got 4 over here. And this side, I've got 4 lots of 1, which is also 4, balanced. And then double checking charges just to make sure we're right. I've still got the 8 plus, I've still got the 1 minus, but now I've got 5 minus. Minus 5, plus 8, minus 1, I believe that gives me plus 2, which is the same as over here, because that's still the only charged thing. So that works out. So it's another successful equation. Let's try one more. The dichromate ion comes up a lot in the IB. They love it. They really, really like it because it's messy. But it actually, if you work through the process, it actually works out absolutely fine, just like all the rest. Just a bit longer. The first thing I'm going to do is I'm going to write it out and I'm going to balance the atoms. Now it's Cr2O7 2 minus. Now that makes Cr3 plus. Now in this case I've got 2 chromes here, but only 1 here. So I need to balance that first. So I'm going to put a 2 there. My next step is to balance the number of oxygen atoms by adding H2O. I've got 7 oxygens here, I need 7 on this side, and the only way I can do that is by adding 7 H2O. Done. My next step is to add hydrogen. Because I've added 7 lots of H2, that's 14 hydrogens. So I need 14 over here in the form of H+, which is 14H+. Okay, done. And then to finish off, I need to add electrons to balance the charge. Now if I look here, I've got plus 14, take away 2, which equals plus 12. However, this side, I've got 2 times 3 plus, which equals 6 plus. This has got the most positive charge, so I need to bring this down with electrons. Going from 6 to 12 is 6, so it's 6E minus. Let's now just check our answer. I've got 14 lots of hydrogen. Here I've got 7 lots of 2, 14 hydrogen. Let's double check our chromium. I've got 2 here. I've also got 2 there. Let's check our oxygen. I've got 7 here. 7 lots of 1 is also 7. So they all work. And charge-wise, I'm just going to double check this once more for your benefit. -6 plus 14 is these numbers here. Take away 2 equals 14, take away plus 6, which is the same as this. So it works. Okay. So another successful one. So that's the first thing, establishing those half equations in acidic solutions. What you then have to do is work on blending those together to form a full redox equation. Now the steps for doing this are very similar to what we've done before. In fact, the first few steps are exactly the same. For those individual half equations, you have to balance the atoms, then the oxygen, then the hydrogen. You then have to add electrons to balance the charge, just like before. Now there's one extra step you've got to do. Once you've got those 2 equations, you then have to balance both equations so the electrons will cancel, and I'll bring this up a little bit later on because it's such an important step. Finally, I have to add the 2 redox reactions together to form an overall redox reaction, and then I check my answer. Now let's try with a straightforward one here, which is PbO2 makes Pb2 plus and Cl minus makes Cl2. I'll work through each half equation first and then we'll do the blending. So the first step is to balance the atoms. Now if I look at PbO2 to Pb2 plus, the atoms actually balance already, so that's good. My next step is to balance the oxygens. I've got 2 here, none over here, so I need 2 oxygens in the form of water, so that's 2 H2O. I then have to add, H plus to balance the hydrogens here. I've got 2 lots of 2, which is 4, so I have to have 4 over here, so I'm just going to squeeze in 4H plus. Sorry that it's got a bit micro small. And I then have to add electrons to balance the charge. Now if you look here, I've got 4 plus there, because 4 lots of 1 plus, and 2 plus here. The only way I can make them both be equal is by taking this down by 2, so I have to add 2E minus. Alright, so that's my half equation, albeit not the most neatly represented one. Let's do the second one, which is a bit easier. So I've got Cl minus making Cl2. The first step is to balance the atoms. 1 chlorine here, 2 chlorine there. I need a 2 there to make it happy. Next step, I need to balance the oxygens and hydrogens. Now that's not relevant here, so I can skip those steps and move straight here. It says add electrons to balance the charge. I've got 2 Cl minus, which is a 2 negative charge, but nothing here. So to make them both balance, I need to add electrons. I can only do it this side to make them both be the same. So it's plus 2E minus. Now that means I've got 2 electrons now on this side, and you can see that the charges work out on both sides, so we're good. My next step is to balance both equations so the electrons will cancel. Now what I mean is that the electrons on one side in one of the equations has to equal the electrons on the other side on the other equation. Now I've got 2 on the left for this equation and 2 on the right for this equation. Now because these are the same, I don't have to do anything, so that's a nice thing to have. And then finally I have to add them together. Now to add them together I literally rewrite it from scratch, but with everything from one side on one side and everything from the other side on the other. So it's 4H plus PbO2 plus 2E minus plus 2Cl minus. That's basically everything here. Produces Pb2 plus 2H2O plus Cl2 plus 2E minus. And that is my redox equation. Now the only thing I need to do now is I need to remove electrons, because they should cancel from my previous step. I've got 2 here, I've got 2 here, and hey presto, it balances. So 4H plus PbO2 plus 2Cl minus produces Pb2 plus 2H2O plus Cl2. Now because I've done lots of this checking with you before, I'm not going to go into crazy depth about it, but I'll just go through it real quick. 4 hydrogens, 2 lots of 2 4 hydrogens, great. 1 lead, great. 2 oxygens, 2 lots of 1 oxygen, great. 2 chlorines, 2 chlorines, great. And finally charge, plus 4, take away 2 is plus 2. Here, this is the only thing charged, which is plus 2, so the charge is also balanced. That is your full redox equation. Let's try another one. I've now got a slightly trickier proposition here, and I'll explain why in a moment. It says balance the atoms in each half equation except OH. Now, what I've got here is C2O4 2 minus making CO2. Now the first thing I need to do is I need to balance them out. So you can see that I've got 2 carbons here, only 1 there, 4 oxygens here, only 2 there. The best way of making this balance is by adding a 2. So that's the atoms balance. Now it says here balanced number of oxygen and hydrogen, but by doing that previous step they're actually already balanced. My oxygen have gone from 4 to 2 lots of 2, which is also 4. So that's good. And there's no hydrogen to deal with, so we can skip that step. Finally, need to add electrons to balance the charge. I've got 2 minus here, nothing here. I have to add 2 electrons here to balance them on both sides, so it's plus 2e minus. Okay. Now let's do it with the next one. Now, I think we've done this before, so I'll go through it as quickly as I can. MnO4 minus, making Mn2 plus. Manganese balance, so my first step is good. Oxygen, 4 here, none here, so I need to add 4H2O. I now need to balance hydrogen by adding 4 lots of 2, which is 8 on this side, so that's 8H plus. Finally, I need to add electrons. 8 plus, take O1, 7 plus. I've only got 2 plus here. I need to bring this down to make it match that, and I need 5 minus to do that, which is 5 electrons. Now, this is the messy bit. My next step, balance both equations so the electrons will cancel. Notice I've got 2 electrons on this side and 5 on this side. If I try and bring them together, the electrons won't cancel, and that is bad news. So you need to find a common factor or a common number which will allow them both to cancel. Now, because this goes up in 5s, which is much larger than going up in 2s, it's much better to find a number which is common that this has, which will cancel with this if you multiply them up. So 2 lots of 5 is 10, which is also a number which 2 can multiply by in order to reach it. So let's multiply this one first of all by 2. So if I times that by 2, that gives me 10e minus plus, and I've got 2 lots of 8, which is 16h plus. I've now got 2 lots of this, which is 2 MnO4 minus, and that makes 2 Mn2 plus 8H2O. So you can see some of the numbers are getting pretty big. Let's have a look at the other one, which is this the C2O4. Now, in order to get to 10 electrons, 2 times 5 equals 10, so everything now has to be times by 5. So now what I've got is 5 C2O4 2 minus, I'll just sort of show you what times by 5, makes 5 lots of 2, which is 10 CO2 plus 10e minus. Now I'm in a position where I can actually bring them together to form one overall redox equation, and I'll do it lower down here. So 10, I'll start with the first one, 10e minus plus 16h plus 2MnO4 minus. Now that deals with all the reactors here, and now I need to add this, plus 5C2O4. Time for the product. I'll start with these two. 2Mn2 plus 8H2O plus 10CO2 plus 10E minus. Now, as we looked before, the electrons need to cancel. So 10 here, 10 here, lovely. So that is what we're left with, and that is your redox equation. I could rewrite it out, and I would rewrite it out as a proper exam style question, except with the electrons removed. Final thing I want to do is I just want to check my answer, so let's just double check it. 16 hydrogens, 8 lots of 2, 16 hydrogens, we're good. 2 lots of magnesium, 2 lots of magnesium, good. 4 lots of oxygen here, 5 times 4 is 20 there, so 8, 2 lots of 4, plus 5 lots of 4, which is 20. I believe gives me 28 oxygen. 8 here, plus 10 lots of 2, which is 20, gives me 28, so the oxygens also balance. So we've done that, we've done that, we've done that. Carbon, 5 lots of 2, which is 10, 10 lots of 1, which is 10, so they also count, or balance out. So you can see that all my atoms balance, my charge balances as well, because I've got 16 plus, or plus 16, take away 2, which equals plus 14. If you look over here, I've got 2 lots of 2 plus, which equals 4 plus. So they balance as well. Oh, almost forgot. The 2 minus. Had a heart attack there. I got the 16, take away the 2, and then I've got to take away 10, and that gives me plus 4. And there's 4 plus there. That just serves to illustrate how easy it is to make mistakes here. You've got to be so careful, and by doing that you could almost see that I made a really small mistake. Although it does illustrate how I could sort of just go back through my working and just double check where I'd made a mistake. So always go through it if you need to, and just make sure that you've written things like that. It's so easy to miss a little number or a little charge and then your whole question's ruined. You've got to do this so carefully. It takes time to get perfect on. Okay, we'll do one more and then we'll call it a day. So here I've got the dichromate ion and I've got this sulfur beast as well. So let's go through this together. So let's do the dichromate first of all. So I've got Cr2O7, 2 minus, and that makes Cr3 plus. Okay. So in this particular example, I need to balance out the number of atoms of chromium first. So I've got Cr2 here, that should be 2Cr. I've then got to balance my oxygens. Okay, so I've got 7 over here, none over here, so I need to add 7H2O. Alright. I've then got to balance my hydrogens. So to balance the hydrogens, I've got 7 lots of 2 hydrogens here, which is 14. I now need 14 here, so I'd add 14H plus. It's getting a bit messy, but we can rewrite it out a little bit later on. So they balance 2. And then finally I need to add electrons to balance the charge. So I've got, on this side I've got 14 plus, take away 2, which is 12 plus. On this side I've got 2 lots of 3 plus, which is 6 plus. In order to make this work, I need to add 6E minus here. So that's that equation, and we've gone through that before. Now let's have a look at this one. I've got SO3, 2 minus, making SO4, 2 minus. Now this is a lot messier. The number of sulfurs are the same, so I'm going to ignore those, but my oxygens are not the same. So I have to add oxygen on one of the sides, and the only side I can really do that with is on this side. So I'm just going to add H2O here, because now I've got 3 oxygens and 1 oxygen, and that makes 4. Alright, so that's good. I now have to add H plus in order to make the whole thing balance out. I've got 2 hydrogens here, none over here, so I'm just going to add 2H plus. Alright. And then finally I need to add electrons to balance it out. So I've got 2 minus here, and 2 minus there, but I've also got 2 plus here. So the overall charge on this side is 0, because 2 plus, take away 2. I've got 2 minus here, but if I add electrons it will take it even further away from 0. So I have to add electrons onto this side, so it's going to be 2E minus plus the rest. Okay? So those are my 2 half equations. Now, I now have to balance both equations so the electrons will cancel, and this is the tricky bit. On this one I've got 6 electrons, but on this one I've only got 2. So in order to make the electrons balance on either side, I can multiply this up, and I can multiply it up by 3, because 3 lots of 2 will make 6 electrons. So multiplying it out, it will be 3SO3 2 minus plus 3H2O will make 6E minus plus 3SO4 2 minus plus, I'm running out of room here, 6H plus. Alright? Now, let's bring them all together. So, this is where room might be a premium. So, I'm going to start with the first equation here, and let's just string it out. So I've got Cr2O7 2 minus plus 14H plus 6E minus. That's the first equation. And then all this stuff. Plus 3 3SO3 2 minus plus 3H2O, and that is this part of the equation and this part of the equation. Forget this because this is the one that wasn't multiplied up before. Now this is going to add to these two and these three things. So it's going to add 2Cr3 plus 7H2O plus 6E minus plus all the other stuff here as well. So plus 3SO4 2 minus plus 6H plus. Now this is the interesting thing. The electrons cancel because I made sure of that when I did the balancing before. But the hydrogens here, some of them will also cancel. I've got 6 here and 14 there. So those can balance with some of those. So 14 take away 6 will leave me with 8. So rewriting it out without all that chaff, I'm just going to put a line there and a line there. I'm going to rewrite it out in this space, okay? So it's Cr2O7 2 minus plus 8H plus 3SO3 2 minus plus 3H2. Oh, the waters were also balanced, so I can actually get rid of those two. So let me just get my eraser. So you can see that I've got 3 hydrogens waters there and 7 there. So all those will disappear and 3 of those will go. So from 7 I go to now 4. So that now actually is not a plus, it's simply going to be an arrow sign. So, get my pen back. So that will make 2Cr3 plus add 4H2O plus 3SO4 2 minus. Now, because this is quite a long, hard one, let's just double check our numbers to make sure we haven't made a mistake. I've got 2 chromiums here, 2 chromiums here. Lovely. I've got 8 hydrogens here, 4 lots of 2, 8 hydrogens there. Lovely. I've got 3 sulfurs and 3 sulfurs. Lovely. Now let's just double check the oxygens because this can be messy. 7 plus 3 lots of 3, which is 9. So it's 7 plus 9, which I believe is 16. Here I've got 4 plus 12, because it's 3 lots of 4, which I also believe is 16. So this is looking really good. Now let's just double check our charges. I'm just going to write down here now for here, so apologies for the confusion, but you can see these, you need lots of paper basically. Right, 2 minus, or minus 2, plus 8, take away 3 lots of 2, which is minus 6, and I believe that equals 0, if I'm not mistaken. Now hopefully this will do the same. 2 lots of 3 plus is 6 plus, 3 lots of 2 minus is 6 minus. So 6 take away 6 is 0. So that is your Redox equation. So you can see that these can get pretty long, okay? Now I'm not going to go through any more examples, but I'd like to talk very quickly about going backwards. Now before I do that, just a couple of things. Sometimes you might have to deal with wordy equations such as this. So sometimes I'll ask you to deduce the half equation for the oxidation of something. And this is the example where they try and blend in redox chemistry with something else, and in this case it'll be organic. Now if you have to do it, you have to work out what the half equation is from a wordy thing. Now this is saying from methanol to methanol. My recommendation here would be to draw it out and then to work out your problem. Now I'm not going to work out the whole problem, but I'm just going to work out this bit. So it says methanol, which is CH3OH, to methanol, which is HCO and H, because it's an aldehyde. If you've got this kind of problem, you need to work out what atoms you've lost. Now in this problem I can see I've got 2 hydrogens, 1 carbon, 1 oxygen, but I have 4 hydrogens over here, and still the carbon and oxygen. I've lost 2 hydrogens. So I've lost a hydrogen there and a hydrogen there. Now your first instinct might be to think, oh yeah, it must be H2. But actually it's not the case. Remember, we're dealing with redox chemistry here. So actually what you probably lost is H+. So to write this out, you'd write CH3OH goes to CH2O, but I've now also got to account for the H2 that's been lost because I need to balance both sides. So it'd be plus 2H+. Now once you've done that, similar to what you've done before, you have to balance the charges. The charge over here is neutral, but the charge over there is +2. Now the only thing I can add, as you can remember, is the electrons, and I can only add that on the right hand side. So I have to add 2e minus, and that's balanced. Okay, and then you just go through the rest of it, and usually they'll give you more information to help you with that. These are the kind of questions where there'll be like 6 steps, and this might be step 3. All right. Okay, finally, very, very quickly, you can actually go back to half equations from a Redox equation. This is actually probably a lot easier than what you've done previously. My advice to do on how to do these is to work with one at a time. So I'm going to start with my manganese. So I know I'm going to go from MnO4 minus all the way to Mn2 plus. And what you can do is you can just sort of spot the things which are going to be needed, okay? Because you can see that this needs oxygen on the left, so you're going to have some on the right, so you're going to have to pour this into it, okay? But you've also got the hydrogen, so you know you're going to have to pour this into it too. Okay, so that's your first Redox equation. Before you go any further though, just double check your charges. I've got 1 minus plus 8, which is plus 7. Over here I've got plus 2. So in order to make them both balance, I need to add electrons to this side. So to go from 7 to 2, I need 5 electrons. And there you go. For the next one, I've got 5 Fe2 plus going to, so I've done that, and I'm going to 5 Fe3 plus. Okay? Atoms are balanced, that's the easy bit. How about charge? 5 lots of 2 plus is 10 plus, but on this side I've got 5 lots of 3 plus, which is 15 plus. The only way I can make them both the same is by bringing this down with electrons, and as you can see, 15 to 10 is 5. At this stage, it's worth double checking things, okay? And the way to double check it is by checking electrons on both. I've got 5 electrons here, I've got 5 electrons here. That's a really good sign, okay? Let's try one more. Now in this case it's a bit messier because I've only got iodine, but again, take your time with it. I'm going to start with this, IO3 minus. Now that's going to go to, I presume, to be I2, but I'm not sure how much. I'll come to that in a second. First of all, before I balance the iodines, I'm going to sort my waters out, and you'll see why I do that in a second. I've got 3 oxygens here, so I need 3 here, which is accounted for by this. Okay. But I also need hydrogen on this side to balance it, which is 3 lots of 2, which is 6, which is accounted for by this. Okay, great. Now, in order to make all of this work, I also need to balance my iodines. Now, I've only got 1 here, but it's telling me I've got 2 here. Now, the only way I can go from 2 to balance with a 1 is by adding a half. Okay? I can't scale up this to make 2, because then this would all be scaled up 2, which doesn't make sense compared to the coefficients I've got here. Because if I put a 2 there, that would give me 6 oxygens, which would mean I need 6 hydrogens, or 6 oxygens here, I mean, in the water. But I've only got 3 in the original equation, so that wouldn't work. Okay, I'm just going to double check charges now. So I've got -1 plus 6, -1 from here, plus 6 from here. That gives me plus 5. But over here I've got no charge, it's just 0. So in order to make this work, I need to bring that down by 5 with 5 electrons, so it's 5e minus. Now let's work out the other one. I've got 5i minus over here, which I'm just going to put over here. And that should make I2, but I'm not sure how many yet. So let's work it out. I need to multiply 2 by a number to equal 5. And you should know that it's 2.5 or 5 over 2. Okay. But I also need to balance charges. I've got 5 negative here, negative 5, but 0 here. Now the only way to make them balance is by bringing this down so it matches -5, which is by adding 5 electrons. Now final check would be with electrons. I've got 5 on this side, I've got 5 on this side, and it works. Okay? So I hope this tutorial has been useful. I know it's been quite long, but it does need that detail in order to get it right. Good luck with the rest of your attempts at doing this. Okay.